Hey, so we're back talking about section 3.3, still the zeros of polynomials. So one more kind of thing we need to address in this section is the P over Q rule. So if you'll find that in your note packet, it's towards one of the last couple of pages. It says the rational zeros theorem. The rational zeros theorem, or also called the P over Q rule, helps us find the zeros of the polynomial. So if we have a polynomial and they've asked you to hunt for the zeros, try to find the solutions, which is really what we do in algebra class. We try to find the solutions to equations. This is one way you can hunt for those, with back to synthetic division that we learned in section 3.2. All right, so again, if you're going to just guess and try to find where these zeros are, if you're hunting for the rational zeros, you can, educated guess would be P over Q. If anything goes into this polynomial evenly with a zero remainder, you know, that's what we mean goes into it evenly, or one of its zeros, the synthetic division K value, the thing that goes out here on the, when we make the housing, this K value of the synthetic division, if it's going to be a zero here, has to be some combination of the constant divided by the lead coefficient of that polynomial. Now this won't account for any imaginary zeros, or if it's square root of 7, 0, if it's some irrational number or imaginary number, this won't find it. But your homework will be contrived to give you problems where this will work for what you're going to see. So it works real nicely to find a lot of the zeros. And again, the P over Q rule, P means find the factors of the constant. So whatever the constant number is, the last number in your polynomial, the constant. And Q is the lead coefficient, the number in front of the biggest exponent. The biggest exponent of your polynomial should be in the front if it's in, standard form. But the largest exponent here is the third degree. So look in front of that. That's what we call the lead coefficient. So that's Q. So factors of the constant divided by factors of the lead coefficient is our guess to try to figure out what will work to divide into this evenly. So if I were to list all the factors of 6, that would be 1, 2, 3, and 6. Everything that goes into 6 evenly. And then factors of 3 would be 1 and 3. So anything that's going to work to give me a zero remainder here has to be some combo of these numbers over these numbers, which would be 1 over 1, 1 over 3, 2 over 1, 2 over 3, 3 over 1, 3 over 3, which is 1, I've already got that, 6 over 1, 6 over 3 would be 2, and I already have that. So that narrows down my list of possible rational zeros to try with synthetic division. And it could be positive or negative. You don't know the sign. So 1, 2, 3, 4, 5, 6, 6 numbers there, and it could be positive or negative, so that doubles the amount. So there's 12 possible rational zeros. Now I'm only looking for 3. It's third degree. At most it has 3 solutions. They might not all be real or rational here. But on your note packet, you can see where I've tried some of those along. So first up, I started with 1. I said, well, does 1 go into it evenly? And you remember synthetic division, we take the coefficients of this polynomial, make sure they don't skip any places on you, line those up, bring down the first number, 3, multiply, add your way across, multiply 7, adding's negative 6, multiplies negative 6, and voila, 0. And so I found one. Actually, that's just great. We found one of the zeros. So 1 is one of its x-intercepts, it's one of its solutions, and then x minus 1 would be one of its factors if we're asked to factor. Well, the good news is if you get a zero remainder, you can build off that list. And now this is actually a quadratic equation. Anytime you have 3 numbers and 0, that's x squared, x, the constant, and the remainder. So we could actually just use the quadratic formula and find the other 2 if you want it. But this is too fun. Let's do it with synthetic division. So next I tried, straight through the list, I tried 1/3. In reality, I'd probably not try the fractions first, but just be on with my notes here, I did 1/3. So 3 times 1/3 is 1. 7 and 1 is 8. 8 times 1/3 is 8 thirds. So that's not 0. That did not work out for me. So either if you're on a marker board, you can just erase it and try something else. So maybe I try 2. If you're going straight down the list. 2 times 3 is 6. That's 13. Nope. That is not 0 either. So I try something else. I tried 3, then I tried 6, then I tried 2/3. 2/3 actually worked for me. So would -3. That would have been better. -3 works. -3 times 3 is -9. 7 minus 9 is -2. That's 6. There's 0. Once you get it down to this, that's actually a linear factor. That's 3x minus 2. So you can just go with that. Or just to see it thoroughly, that it comes from this list. The other one that works is positive 2/3. 2/3 times 3 is 2. Then there's your 0. So 1, 2, 3, they're all rational zeros just because this was a good example to demonstrate 3 real rational zeros. And if you graph these all show up on your x-axis because they're real. All right, so then we could factor it. At the bottom of the page, if you found the zeros, you actually just factored that polynomial. So if 1 is a 0, then x minus 1 is a factor. If -3 is a 0, x plus 3 is a factor. That would be x minus 2/3, but you wouldn't want to write it like that. So if you get a fraction 0, pull the 3 to the front there and make it 3x minus 2. So that's how you would write, and now you have factored a polynomial without having that guess and check, I guess, that we hate so much when we're trying to solve quadratics. You might like this better. So it's a more exact method where you just multiply and add your way through, and you can see the flow of it. I feel like students like synthetic division more than they like that guess and check method. Okay, let's try it then on the next page. You have a you try. So pause the video, try exactly what we just did there on number 17. It says, write out all the potential zeros. What would you try for this? And in your homework, it asks you to do things like that. List all the potential rational zeros. So it'd be factors of 8, which would be 1, 2, 4, and 8. Again, that's factors of the constant. P is factors of the constant, so that 8. Divided by factors Q of the lead coefficient, which is just a 1 here. I always appreciate when it's just a 1. That makes it easier because all of these divided by 1 just stay the same. So the list would be 1, 2, 4, and 8, and it could be plus or minus. And that's all we would say on that 17. That's the list of potential roots or zeros. Number 18, let's do that again. See if you can list all the possibilities. This one has a lot more going on here. So once again, we have the 8. So just like before, I have 1, 2, 4, and 8 factors of the constant. Then factors of the lead coefficient. What all goes into 15? 1 goes into everything. So you've always got 1 as a chance. Then there's 3 and 5 and 15. So any combo of these things over these things. So let's write this out. I'll start with 1, some systematic way. 1 over 1, 1 over 3, 1 over 5, 1 over 15. Then do 2, 2 over 1, 2 over 3, 2 over 5, 2 over 15. Then 4, 4 over 1, 4 over 3, 4 over 5, 4 over 15. And lastly, 8, 8 over 1, 8 over 3, 8 over 5, and 8 over 15. And it could be plus or minus. That was a hardy list there. That would be a lot harder. And that's what makes it harder when we used to do the guessing and checking to factor quadratics, is if you had numbers like 15 and 8, there was a lot of combos. So those do make it harder. But we're only looking for 3 solutions, right? And you might just look on your graphing calculator and see which ones work. Wherever it cuts through the x-axis, that's the answer. So that would help us get going. And some of your homework you do, it does say, given that 2 works or something. It gives you a clue to get you started. But that would be the list that we would start working through. Okay, number 19, we're going to actually factor this one. So we're going to use our theorem, but then carry it on to factor. So if we were trying to factor f of x or y equals a third degree polynomial, what I would try guessing, if you didn't give me anything to go on or any clues, I would guess things that are factors of 10 divided by factors of 2, which would be 1, 2, 5, and 10, factors of 10, and then 2 would be 1 and 2. So anything that's a combo of that. So I want to try 1 just straight out and see if 1 works. 1 is pretty much a factor of everything, you know, because it goes into everything. So 1 is a good guess to get this started. Oh, don't think I made it. No, not a 0 remainder. So 1 did not work. Maybe -1 though. Nope. That does not give me a 0 remainder. So then I'll work my way down the line. Maybe it's 2. But this is what you do. You just keep working through synthetic division, trying to get a 1 remainder. Nope. That remainder is -60, so I'm failing on that. Let me tell you this though, because we're going to kind of sum it up at the bottom. There's this summary. And maybe I didn't put it on this one. Maybe it's on your next handout. There is a rule that says if these signs alternate, 2, -1, oh, I didn't completely alternate. If this would have been positive, negative, it means look no further that way from that negative number, like don't try -5, don't try -10. You've bounded it that way. So that's a clue that, and I think that shows up in your next section. But that didn't actually happen there. Do you all already know what it is? Feel free to pause the video and find your answer. I'm going to try -5 for no special reason. Oh, that's not it. Nope. Try +5. In a minute, I'm going to look at my calculator. Oh, I might have it now. I was just about to give up and look at my calculator. So there we've got a 0. So once you get a 0, yes, that's great. Now you've got it down to a quadratic. You can either keep with this guessing rule, taking from your list, or you can use the quadratic equation. This is now a quadratic. This would be 2x squared, 5x, and 2. And you might just find it by the factoring method. 2x times 1x plus 1 times plus 2. And I kind of see that, but I know I teach math, so that's what I do. So, you know, if you don't like that method, keep guessing and checking there. But this would FOIL together to give me 5x in the middle. It would FOIL together correctly. So once you get it down to a quadratic, you may just use your old style factoring method to guess and check it that way and FOIL it, or you can keep guessing. -2 actually worked. I can't remember if I tried that one or not actually, but -2 should have worked. I might have messed that up. Did I try +2 or -2? I might have to rewind the video to see, but -2 actually does work. If I tried that, maybe I mismultiplied. -2 does give you a 0, and then the other one is actually, I think it's -1/2. -1/2 times 2 is -1, so that gives you, so you've got 1, 2, 3 zeros. If you're graphing it, those are the 3 places it crosses the x-axis. In factored form, we do the opposite sign, so it's x minus 5. That'll be x plus 2, and that will be 2x plus 1. And there you have the factored polynomial when asked to factor. Now, on number 20, it's going to tell you that you've got a multiplicity. If it uses the word multiplicity to give you a hint, it means you can use that same number. Like if it said -2 is a multiplicity, not only can I use it once to get a 0, but I can use it again. A multiplicity means the exact same thing works however many times the multiplicity is. Like if it's 2, it works 2. Okay, let's see. I'm probably going to have to come in one more time on the video, finish up this little lecture. So I will see you in just a bit.